Thank you very much. Hi, everybody. Hi, welcome. Thank you for being here. I'm Sebastian Garcia. Very fast, if you scan that QR code there, you will see the slides moving in your screen. So if you don't see exactly, because this is far away, we're like 20 meters from you, then you will see the whole presentation in your laptop or notebook moving with me. Okay, so we are going to be doing from billion queries to action, how DNS4EU transforms threat defense. I'm Sebastian Garcia from the Stratosphere Laboratory in the Czech Technical University in Prague. This research was done with Tigran organization that is not here. So, what are we going to be doing? So, how to find new malicious domains in all the DNS traffic of the DNS4EU project. That's our goal. That's what we are going to be talking about. But what is the DNS4EU project? So who here knows or hear about the DNS or is using the DNS4EU project? Some people there, oh, that's nice. So DNS4EU, if you don't know, it's the official DNS resolution infrastructure of EU. It's a project that's right now 3 years long, a consortium of a lot of people that have been working how to make this happen in EU. And the issue is that before, a lot of DNS traffic of EU citizens end up in the hands of private companies outside the EU, and EU didn't like that. So they want this sovereignty, privacy, and application of EU regulations. So they create this project, and that you can do for free. So it was born to offer private and secure DNS resolution in EU. And if you want to join, you just can go there. Those are the IP addresses. You just use DNS servers for free, and then you have protection, IPv4 and IPv6, in case you're interested, with many applications, okay? So what is the scale problem here? Well, the scale is that it's planned to serve 100 million users. That's a lot of people. And it needs to be doing this very fast. So there is a federated architecture, public cloud, ISP, for governments, a huge thing inside DNS4EU, guaranteeing low latency, and there is a lot of balance between the storage, right, the analysis, and should scale up, okay? So this is the whole DNS4EU. Inside this project, the Stratosphere Laboratory is doing the security, part of the security, for finding new malicious domains only, okay? Other groups are doing other things. So for us, in Stratosphere Laboratory, we need to consume all this data, and we need to start finding stuff. So this is our infrastructure. How do you consume that? We are going to go through this slowly, so you don't have to read it from here. But the infrastructure starts with reading from Kafka's. Like, a lot of this is like bringing directly from Kafka. That means a huge amount of traffic. So we are reading directly from there with consumers, and that is roughly the raw data that we have. So we have the answers and the answer IP. The client IP is completely anonymized, so we have no idea who are the client's IPs or nothing about them. We have the domains, level 1, 2, the query type, the timestamps, and TTL, and that's it. Not a lot of information. We don't have URLs like Antonia had. We have nothing like that. We just have queries. So it's a little bit tough to work with. So we are consuming all this from the Kafka, from Whalebone, one of the main part of the group, and we are bringing this into our own ClickHouse. Once that is inside ClickHouse, then we can start trying to do the consuming. So in ClickHouse, we are starting the processes, and we have two main views. The main view table is domains. We go domain by domain, and we start aggregating features. How many times we see this domain, right? Like, which are the TTL statistics? How many unique IPs had in the last 24 hours? A lot of information and features we're extracting per domains. And then we do the same for each client and each domain. So if each of you is going to Google, every time it's going to Google, we have statistics for that. How many times and when, stuff like that. So we are having these two main views to try to analyze the problem, okay? After this, we are taking information from the views. This is in parallel, right? All together, the whole day in parallel. And then we are first doing a pre-processing, and we are deleting the first 1,000 domains in the Franco list. This is because the data is so huge that you end up analyzing 90% of the time www.google.com. And remember that we are not looking for phishing, we are not looking for URLs, it's only the domain. So the probability that www.google.com is going to be malicious in the future, well, it's not 0, but it's very low. So we have the top 1,000 domains of the world that we are going to be deleting right there. This is for performance issues, okay? Then we extract more features, right? Like aggregate metrics of the domain name entropy, domain name entropy, and others are done here. And in the client domain, we are doing other type of analysis, like power spectral density. That's a technique that you take times of queries and then you analyze the frequency, kind of the fast Fourier transformation, but a little bit better. So we do some analysis on top of these timings for the domains and the client domains, okay? Once we have these views and pre-processing inside infrastructure, we move into the machine learning. So the machine learning is, again, parallelize different Dockers, each one running their own algorithm. And the main ones here are isolation forest, that is a clustering algorithm that detects anomalies via tree-based isolation. Then we are doing dbScan. Then we are doing GMM, the Gaussian mixed models. We try many more, and there are some things behind the scenes that are not here, neural networks, stuff like that. But these ones were so far the best for us. Not every technique is super good here. So we are running these. Pay attention, that is for the domains and the client's domain data, okay? All of these ones. And after this machine learning processing, we go into the post-processing. That means things like, hey, take the output of each of those and merge together, and then generate one final threat intelligence feed that we can give to the rest of DNS4EU to block the traffic. So it's a list of thousands and thousands of domains every day, as fast as possible, right? And every day we are repeating this. So kind of the concept is moving and moving and moving. So about performance, we are having roughly 15,000 queries per second, which is roughly 54 million queries per hour, which is roughly 1.2 billion queries per day. So it's a lot of traffic. And this is the key. Like, it's a little bit simpler to work with smaller data sets and have nice false positive rates and everything. In that level of queries, it's extremely hard. Not to mention that it's like 1 terabyte per week, a little bit more actually now. Okay? So that's the real problem, how we deal with that amount of data. And to deal with the amount of data, we said at the beginning that we are going to be doing new malicious domain. What does it mean? What is new? What is malicious, right? So this is extremely hard, and that means should not be in any threat intelligence list in the moment of detection. The domain should not be in any blacklist, should not be in any historical reports, should not be any previous knowledge. That is kind of new, tough. Also, malicious, we have some constraints. We don't want to do DJ, that's another neural network that is already running. We don't want to do phishing, that's another group, the certain Poland doing this. We don't want to do DOS, that's the sysadmin people. Like, there are some groups taking care of other things. What is left? Malware command and control and delivery, exfiltration, botnet, spyware, and all this infrastructure, okay? So the problem is hard, it's super new, and the definitions change, and how to search for these kind of hard-to-define things that nobody saw before in a large number of data. For that, we have the real hard problem, and that's the features. What are we looking at? What are the values that we're looking at? And to find this correct set of features from available data is tough. You can do feature selection automatic with AI, you can do correlation, you can do a lot of things. You need to choose a set of features that make sense and work nice. And remember, we don't have a lot of features to start with. We just have like 10 features. So we need to extract all the information somehow from there. Also, the client ID changes every 24 hours, so we cannot do like long-term analysis of your behavior or nothing like that. Your IP is completely anonymized and change every day. So not to mention NAT and other ISP providers. So it's extremely hard to go client by client. And clients are not IPs, yes, so no geolocation, no threat intelligence, and things like that. That being said, we could get some features, so this is not all of them, but it's most of them. A lot of the TTL, a lot with the counts, a lot of number of requests, answer IPs, entropy for the IPs, sharing count, the dominant frequency, that is from the power spectral analysis, right? So we see how you're asking in time and the frequency, so we extract the features there. A lot respecting the entropy. So we take as much as we can, and then we change them a little bit. And remember, if your features do not help you separate the data, there is no magic here, right? Like you cannot have some magic AI later that finds it. Like the features should be good enough, should have some sense, should go in some direction. Maybe not for you human, but yes for the algorithms, okay? So if the features cannot separate the data, well, nothing there that you can do. So the AI models in 2 steps. I'm not gonna go deep into the models, but just for you to have an idea. First, we do clustering and anomaly detection because we have a lot of data. So we start clustering and clustering and clustering. That means in isolation forest, we detect anomalies by isolating the point through the random splits in the tree, which means that anomalies, if you have the tree, the anomalies are the ones that have the shortest path. Okay? So that's how the algorithm works to find the anomalies. Remember, anomalies is not malicious. Anomalies is not benign. Anomalies is anomalies. We don't know. It's things to look, okay? Then we have the Gaussian mixture model. That is like a little bit statistics there, but it's shaping, fitting this probability of all the distributions, like looking at the data and trying to find the probability distributions, and then identifies which is the likelihood of each new point belonging to these models, okay? And the last one is DBScan, traditional DBScan. There are like 10 variants. This is the best for us. It's a clustering method based on density, which means it's kind of getting stuff together, and then whatever is not close enough, density speaking, is anomaly, okay? So we have anomalies from all of those, and at the end, we are doing false positive reduction. And that's actually another problem. So this is kind of fine, let's say. False positive reduction, it's a problem here, because like Antonio was saying, like you need to deal with those. And this is going to hit hard. Remember, 1.2 billion queries. And the majority are benign. So how do you deal with here? How do you detect most of what you want to detect without having errors? Well, you cannot, but you can minimize. So I'm going to go a little bit deep here in the technique of Bayes inference, okay? So follow. We start with our prior belief, we as human, assuming that before we see the data, we believe something. For example, only about 5% of the domains are malicious, or only about 1%, whatever. Like you have something that you know because you are checking data, you have previous experiments, somehow you know that, yeah, 0.01% is usually malicious, right? So that is your prior belief. And then you have another one like, hey, this threat intelligence feed is usually bad, or it's usually good, or I don't know, sometimes it works, sometimes it doesn't. Those are your prior beliefs in your things coming, okay? We need to work with that. That is what is the power here. So for each of these assumptions, we are recording both the percentage, 0.01% is malicious, and the confidence we have, how sure you are that threat intelligence release is actually bad. I'm not so sure, like 50%, right? So you really work with these numbers. They don't have to be perfect. You don't have to be really good. You just need to have some sense here. Then we have this strong confidence that behaves lots of past experience. So the confidence is like your past experience. I have been working with the threat intelligence feed for 5 years, and it's actually very good, right? That is a strong confidence. And if you have a weak confidence, that's fine. Don't worry, because the weak confidence we can change later. We're going to be adapting this, okay? So far, you have these priors that gives you a model of a sensible baseline. You're not starting from scratch. You have some prior experience. Once you have that, in the technique of Bayes inference, a new domain is arriving, and what you are doing is taking evidence, like it's in a threat intelligence list, or it's an anomaly model. This anomaly say anomaly. This anomaly model didn't say anomaly. All of these are evidences, okay? So we are collecting these things. For each domain, you are going to model the probability that the domain is malicious and simultaneously the probability that it's benign. It's not one of the other, it's both. You are modeling at the same time. This is the probability of you being malicious, and this is of you being benign. We compare each evidence that is arriving. You are anomalous, you are in that threat intelligence list, you are in virus total or whatever. We are comparing the evidence against your previous beliefs. And this is like a question. Does it fit in the malicious story? I'm gathering more evidence. Does it make sense that this is more malicious? Or does it make sense in the benign story? Is the evidence pushing you to believe this is good, or is the evidence pushing you to believe that this is bad? And remember, each evidence have different probabilities of being correct and different confidences that you have. So behind the scenes, there are no numbers. In Bayes inference, you work with probability distributions. After that, each of these evidence is pushing your belief. You are changing what you think because of that. At the end, you combine this with the prior malicious rate story, and you have the posterior. The posterior is what you call your updated belief. I believe that. Now, after the evidence, I change what I thought. That is your posterior. You are adapting in time. So the update probability that the domain is malicious plus the view of the remaining uncertainty. So for each domain, the more evidence, the better. You collect evidence, collect, and says, I was not sure, but after that, I'm 10% more sure. And now, 5%. And now, and there is a ratio, and then you have a score, and then you can cut whatever you want. You say, well, I just want to be more than 90% sure, or 80% sure, or something like that. So what do we do with this? That's fine, but remember, these are new domains. We have no labels here. So how do we validate? How do we know that we are not making mistakes? I mean, we are making mistakes, but how do we measure the mistakes? So in here, for each domain, we wait, and then next day, we test. The moment we have the list, we publish, and those domains are being blocked right now. We cannot stop that. But we need to know one day later if we were correct or not and how much. And then we adapt for the next day. So our learning is one day behind. We cannot do better than that. In the moment, you are blocked, some mistakes, and then we learn a day later. And then we adapt, and we adapt, and we adapt. So first evidence that we are checking after the fact is, okay, what is the new position in the trunk list? Did it move? We check like 15 threat intelligence feeds, like are now appearing a threat intelligence feed or not? Can we consult all these APIs, Virus Total, URScan, OTX, Gray Noise, CrowdSec? We consume. After the fact, we wait for the evidence to appear, and then we say, okay, what happened here? And what happens is something like this. This is a summary. So you start with a new domain, and then you say, is it now in the trunk list or not? Then, is it in any of your threat intelligence feeds or not? This is a simplification, right? And then the last one is Virus Total, because it has all the information. And hey, is it Virus Total, and to which, how many detections has or not? And then at the end, we take a decision. So imagine, for example, you have a new domain. All these domains are domains we said we are going to be blocking, okay? All the domains are the domains in our list, not everything. Thank you. So it's like, in trunk list, okay, that means that probably you are a little bit more benign-ish. Let's go with that one. And then you are not in any feed. And then you are not in Virus Total, so you are benign with a score of 0. But, for example, if you are in the trunk list, which means you are a little bit, benign, and then you are not in any feed, but suddenly you appear in Virus Total, oh, that's strange. Usually first appears in Virus Total, then appears in the threat intelligence list, then in the reports, right? So there is a time delay. So for each of these combinations, we roughly put a score, and then we see how we are doing. This is verification. It's like, are we messing a lot? Or how do we know? And roughly the numbers are around there. Like in the score 0, which is completely domains that are for sure benign, we block them, but are for sure benign, are roughly 0.1, 0.09, stuff like that. And then domains we say, you should block that, but the score is 1, that is the majority. It's like, yeah, benigns. That's why you can cut. You can say, I don't want to block more than score 4. You decide, okay? So you decide from the list. And then score 2, 0.1, score 3, the suspicious ones, 6%. Those are actually very interesting because score 3 is there like they are not in Tranco list, they are in some feed, and they are not in various total. It's like, oh, what's going on here? It's like, probably you're not super malicious, but somebody thinks that you did something. So that's score 3. And then score 5, that will have like roughly 20%. So then up to you and DNS4EU, how deep they are going into the list, okay? And by the way, that doesn't mean that they are really benign. Maybe they are phishing appearing in a week, but the algorithm says you should pay attention there. So some real cases. There are many, right? For you to have an idea. Logs2blog.com, VirusTotal says super fine, don't worry, nothing. But actually, and it's in the top 100,000 K of Tranco list, so pretty popular. But this is an official domain. Whoa. That is an official domain. Yes, allow, of course. For the group Blue Delta target key network. Yeah, I should have thought about that one, right? Are you sure you want to go there? Stop whatever you're doing. So this is one in Blue Delta, Gru's group, targeting European people in the Spanish campaigns. So that was a real malware domain that we got, and it was not detected correctly. And then we have many like this. This is a real list like from days ago, right? Domains and domains and domains and domains and domains. Some of them appear, some of them we have no idea, some of them we can give names, some of them are tests, we don't know, like new malware coming, it's very hard to say. For example, this one, Adobe US update files.digital, malware distribution is a command and control for brand impression. So this is really malware, it was captured there. Another one with connects.zoom.com, fake software update, that was easy. We have DNS0.org, used for DNS tunneling a lot. We see many of these ones. You have IPs there, you have all the information we have. We have the lestoutresults.com. This is actually Predator spyware, and we see Predator spyware like a lot in infrastructure, and we see like clients, and we see IPs. Unfortunately, we cannot contact the clients because we don't know the clients. So if you're using DNS4EU, you're going to be blocked. If not, well, it's depending on what you're using for security. Predator spyware delivery, another command and control, noisyball.com. We see these two. Mercharena.biz is a Luma stealer, also there. So many of these ones, and we can talk later. But in conclusion for us, a strong, resilient, and automated and monitored infrastructure is key. When we start, we say we need a strong visibility, and we need to know what are we missing, including if we are not consuming everything correctly. Choose what to detect and what not to detect. We cannot detect everything, that's not working. You need to have each type in a different problem with different techniques. And then false positive reduction, of course, is critical, as others have said. You need to work in your false positives, right? So I'm going to stop here. And thank you very much for coming and staying.